we can start a new topic, JavaBeans topic, part 8.3, Basics of JavaBeans. First, so let's look at the what is JavaBean? What is the meaning of JavaBean? Okay, yeah. JavaBeans are software components. So what are the software components used in Java software development? Here, in order to explain the background, I may like to give you a little bit history of JavaBean. The software components in history used in Java desktop application. Development. Yeah. At that time, for desktop application development, in order to make the development very fast, very efficient, usually people need to put a lot of GUI components, graphical user interface components. Okay? Yeah. I mean, just like the Microsoft Basic Visual C++ tools. Yeah. Here, Java team, they wanted to do the same thing, because the Microsoft was very successful in desktop application development. So they want to learn from Microsoft way, successful way. Yeah. The same thing as Microsoft did. In order to make the GUI development very fast, there are many little icons, right? Toolbox, icons, each one for one GUI component, right? For example, a button, suppose you want to add a button, you drag and drop, right? Sometimes you may like to put some relatively more advanced GUI components like calendar, right? So calendar, drag and drop, right? Calculator, drag and drop, okay? Things like that. So the Java team, so they develop each component as one JavaBean, okay? So one JavaBean, yeah, many JavaBeans, yeah. So they create nice interfaces, yeah. So when the JavaBean component developed ready, so they can plug in, so they can install into the, that platform, yeah. So let's call the platform easily, yeah. So in that way, so they can build some very powerful, very sophisticated desktop applications in a quick way, yeah. All right, so that's the original idea, yeah. But later, the whole industry, IT, the whole industry quickly moved to web applications. So the market share of the desktop application reduced greatly, and the market share of the web application grows extremely fast. Okay. So the desktop tools, used in a very small portion of the time. And for the web applications, so people need to use more and more tools in the development. So for that reason, so then this JavaBean, because there is already proved technology. So the proven, let's call the proven technology already there. Okay, JavaBean. So then the Java team, so they moved JavaBean technology and use it in the web application development. So that is the, the history, the background about the JavaBeans. So with that background, now when we talk about JavaBeans, so you can see, so a lot of things you can understand, naturally. All right. Next, JavaBean components are not web components. Here, let me explain. So why not web components? Because we use JavaBean components in our web applications, but we do not treat JavaBean components as web components. Why is that? The reason is very straightforward. When we talk about web components, those components rely on the web environment, the server, web, typical web environment, the server environment, rely on that. Okay, so that then we call them web components. Otherwise, if they can be used outside the web environment, how can you call them web components, right? But JavaBean can be used outside the web environment, desktop environment, they do not rely on web servers. So they can be run, in the usual situation. So that's the reason. Then, because when we talk about the web components, I may like to give you, so what are the web components? Servlets. Rely on web environment, right? So without server, how can you run servlets? Okay, JSP basically servlets. Also rely on web environment. But there is another one we haven't learned, called web services. Technology. Web services are very useful technology. So if I have chance, I may talk about that. Very useful technology. Because using web services, you can build one web application from web servers at different locations. Not necessarily in one location. You can distribute one big web applications in different locations, but work as one integrated web application. So that is a very powerful scenario. But the web services, the technology built on top of the server technology. The underlying implementation foundation is server technology. So we mean these three types of web components. All right. Next, another concept related to JavaBeans. JavaBean must be serializable. This is another very important concept. Some of you may have the experience. When you work on some Java classes, sometimes you may see this word, serializable. If you pay attention to when we use Eclipse to generate servlets, if you look at the code carefully, you can see somewhere serializable ID, right? Yeah. So someplace you can see, serializable, something like that, ID. Yeah. So next time when we see it, I will point that out. Yeah. So you may have chance to see this word before, but you may not understand the meaning of it. So today, in this video, I will explain the meaning of serializable. Yeah. I will spend quite some time to explain this concept. Yeah. All right. Need to send data in JavaBeans through network. All right, so JavaBeans typically we use as data structure. We use JavaBeans as data structure. So the data we want to send between client and the server, we want to store in JavaBean most of the time. Yeah, sometimes maybe not, but most of the time we use JavaBean to store the data. Okay, so then think about, now consider the scenario. Our web application could be distributed in different locations. Location 1 here, location 2 there. Okay, geological locations. Okay, yeah. In the world, different locations. Location 3 there. Okay, yeah. The servers in different locations. The servers could be in different machines, right? Windows machine, Linux, Mac, different types of servers used in different locations. All right. So then when you do communications among different machine, different system, different locations in the world, how do you guarantee the JavaBean you send from one location, one machine to another location, completely different machine, it can still work perfectly, right? In a perfect way. Yeah. How can you guarantee that? Okay? It is very hard. You need to consider if we know a JavaBean object, it is a binary data, right? Binary data sent through network. Yeah. Connection. Yeah. Networking. Yeah. Yeah. TCP IP, binary data, the string, that kind of thing. How do you know the data sent? Yeah, because different machines using a different type of binary code, right? Mac, Windows, Linux, they use different types of binary code. How can you make the translation to work well, right? So a lot of technical issues. Yeah. In order to guarantee your JavaBean work as expected everywhere in the world, in every different Java system, this concept is created, serializable concept created. In other words, if we make JavaBean serializable, then it is guaranteed it can work everywhere in the world. The serializable property makes sure that every JavaBean works as expected everywhere in the world, every type of Java machines. Yeah. So that is the reason, the goal to create this concept. Yeah. All right. How to make it? Yeah. I will explain. Yeah. How do you implement that idea? Idea looks nice, but how do you get it? Yeah. So we need to know that. Yeah. All right. First, Java. Yeah. We try to understand JavaBeans. Anything special about JavaBeans? Yeah. We want to see that. Yeah. They are Java classes that have properties. Yeah. The properties actually nothing special, just the private instance variables in regular Java classes. So here, JavaBeans are special Java classes. First, they're Java classes, normal Java classes, but they need to follow some rules. The rules, we call it JavaBean specification. They need to follow. So a lot of rules in JavaBean specifications. Yeah. All right. So then, if a Java class is a valid JavaBean, then we change, in Java classes, those things, those members we call private instance variables in JavaBean, we call properties. Properties. So we give special names, properties. Yeah. So in our discussion, when we talk about JavaBean properties, so they're just private instance variables inside those JavaBean classes. All right. Store data in properties. Yeah, because we know Java classes store data in instance variables. Yeah. With setters and getters supporting data binding. Yeah. Here, a lot of things to explain here in this short sentence. A lot of things to explain. First, setters and getters. Special methods. Special methods. Java methods. But they start with set something, set property, get property. So those methods we call setters, getters. Okay? Through those methods, we can access data stored in JavaBeans. Yeah. Retrieve them and update, change the values of those properties. Yeah. Yeah. But other than setters and getters, your JavaBeans can still have other methods, other data processing methods. Okay, yeah, no problem. Yeah, but some of the methods are setters and getters. Yeah. Other methods you can use to do other business. Yeah. All right, yeah. Then another important, very important concept, data binding concept. What's that data binding concept? Data binding. Bind to what? Data bind to what? What's the data binding? Actually, this is a big topic. Data binding is a big, big topic. Yeah. Later, I will spend a lot of time talk about data binding. Yeah. But here, I just let you know. So what's that data binding? Yeah. Two sides you want to do data binding. HTML forms. Because in the forms, the user enter input data. Input data through form fields. Through form fields. Okay? All right. Then this side, that HTML user's interface, the page, the user can enter input. Yeah. Then this side, remember, JavaBeans properties are used to carry data, right? The user's data carried from client side to server side, from server side to client side, right? Yeah, two-way transmissions, JavaBean. Yeah. Then, now, there is automatic data copy between HTML form fields and the JavaBean properties. That's called data binding. Automatic. It should be automatic. Automatic. Okay? Automatic data copy. Yeah. How can that happen? Right now it is too early. Yeah. Because right now we have not learned enough background knowledge to understand that details. So I need to delay. At an appropriate time, I will explain that. Here, I just give you some overview, high level. Yeah. Later, we will get into deeper and deeper in this topic, data binding topic. All right, so next topic. Serializable. Yeah, I come back to serializable. All right, yeah. Serializable objects in scopes. Serialization concept. The process of converting an object into a stream of bytes. In the communication, you need to have a stream object, right? Communication, the channel created, okay? Yeah, connecting different computers. Yeah. So the binary data, yeah, send through this communication channel as a stream of bytes. Yeah, yeah. All right, yeah. All right. So object. Yeah. Then the receiver side, sending side, yeah, two ways. After you receive it, where do you store it? You need to put somewhere, right? Yeah, store it. Yeah. All right, so store the object or transmit it to memory, main memory. Sometimes you use it in memory. A database, sometimes you may want to store in a database, right? Yeah, database, we can store object. There is special type of database that can store objects, yeah, or a file. Yeah, a file we mean stored in hard disk. Okay, the main memory, yeah. Okay, stored in different places. Okay, yeah. So your Java objects could be stored in different places, different mediums. Okay, yeah. Then for that reason, you need to consider the compatibility issue. So from this diagram, so look at this diagram. So the object represented as a stream of bytes, binary data, yeah, then stored in different mediums, right? Yeah, yeah. Main memory, database, hard disk. hard drive. Yeah. Then there is an issue. Yeah. There is this issue. Yeah. When you store in different places, can you recover it? Yeah. Later, you want to get those objects back and use it in your business. Recover them. Okay? If the objects somewhere, you store somewhere, but later, after you retrieve it, you cannot recover to the original object, the data get corrupted, then you cannot use it for your business. So we need to make sure the object retrieved exactly the same as the original object. How do you make that? How do you make that? How do you guarantee that? Serialization. If the object can be serialized, then it can be recovered completely. If the object cannot be serialized, then you may not be able to recover to the original object. So that's this concept. But with this explanation, you couldn't understand what is the really serialization, the meaning of serialization. Yep. This is an abstract word. I know its purpose, but I do not know its exact meaning. Yep. Here, let me give you a little more explanation. All right. The binary string, the binary object representation in main memory, you know, that environment, it is different from the environment in hard disk. Okay, yeah, hard disk, different. Yeah. So that means some of the special characters or byte representations in main memory may not exist in the hard drive media storage format. May not exist. Different. Okay? So if you use some, let me just use some plain way, simple way. If some symbol that could be represented in main memory cannot be represented in hard drive, then this object is not serializable. So we define it that way. Okay? Only when the symbol in main memory can be also represented in hard disk and vice versa, you know, all different places can be represented, then that symbol is serializable. Okay? All right. So that's the meaning. So we define serializable based on that meaning. Okay? So the binary symbol that can be represented everywhere. Yeah. Every storage type, then we call that symbol is serializable. How about that? Okay? Yeah. We may not know that details, but Java knows it. Java knows what kind of symbols are serializable. Yeah. We don't need to worry. Java knows that. Yeah. We just know that concept. Okay? All right. So then with that, now you can understand the main purpose to save the state of the object, the state of an object, in order to be able to recreate it, recover it, reproduce it when needed from different storage media. Yeah. So that's the whole story. Yeah. So I hope you understand this background information. Yeah. Otherwise, later when we learn some more properties, it may not be easy to understand. Yeah. All right, the next. Serializable Java objects. Now we want to go to the programming side. Yeah. It's abstract, but we have that background, so we don't want to get into the details. We just want to know that if an object is serializable, then we can transmit to everywhere, no matter what location, what system, what environment they can use as the original one all the time. That's it. Yeah. Now we need to work on it. We need to use them in our programs. Yeah. A Java object is serializable if its class or any of its superclass implements either this interface, serializable interface, yeah, or subinterface, externalizable. Yeah. All right, so that's the definition. Now, that's the requirement to make a Java class serializable. Yeah. But most of the time, we use the serializable interface. Okay. Yeah. Later, I will explain the serializable interface. Yeah. Okay. All right. All right. Yeah. How special is this serializable interface? Yeah. Develop serializable classes. Yeah. We want to develop JavaBeans. JavaBeans must be serializable. Okay. Yeah. In order to use them in a distributed system. Distributed system. The purpose using serializable JavaBeans mainly so you won't have any problem in a distributed system. Yeah. Implement serializable interface. The first thing you need to do, you need to implement a serializable interface. Yeah. All right. But later, actually, there is something more related to this point. Yeah. Yeah. It is optional. Yeah. Later, I will explain. Yeah. Although it becomes optional. So why is that? I will explain that. Yeah. At the bottom of the slide, you will see that. All right. First, this interface is a tag interface. Tag. Yeah? Attach a tag on it. Okay? Attach a tag on it. Tag interface. So what's that? A tag interface. A tag on a product. Yeah. No method declared in it. We know for a user interface, it should contain a set of methods to be implemented. That's the interface, the meaning, original meaning of the interface. But tag interface is very special. There is no method declared inside it. Yeah. Then you may wonder why it is useful. If there is no method declared in it, why it is useful? It is used for some special purpose. This one, serializable, is one. Serializable, if you implement this interface, you do not need to implement any method inside it. There is no method in it. You do not need to implement any. But it looks like your class is attached a special tag, serializable tag attached on it. Okay? Yeah. Then there are some consequences. After you attach this serializable tag, there are some consequences. Yeah. All right. Yeah. When your class implements it, the consequence is this. The compiler in IDE, so we use the compiler in IDE, automatic. In Eclipse, it does the compilation automatically. You do not see it, you do not notice it, but it happens behind the scene. Yeah. So the compiler will check if your class is serializable. If not, it would complain. Okay? Now, that's the reason we use the serializable interface. Yeah. All right. So the compiler can detect you have the serializable interface implemented. You have this tag on your class. So the compiler does the routine check line by line. Which line could cause unserializable thing, it will complain. Yeah. So this line make your class not serializable. You have to fix it. Otherwise, your class cannot get compiled. Okay? Yeah. That kind of complaint. Yeah. That's the consequence. That's the consequence you use the serializable tag. Okay? Yeah. All right. If your class does not implement serializable interface, what will happen? The compiler does not do the check. The compiler cannot see the tag, right? Serializable, that tag, cannot see it. So the compiler assumes you do not want your class to be serializable. The compiler does not have the responsibility to do the check. Okay? Yeah. So that's the consequence. The compiler does not check it. Yeah, not if. Check it for you. Yeah. You are responsible to make it serializable. It's your responsibility. If you still want your JavaBeans serializable, it's your responsibility for that. Yeah. All right. That's no problem, because for experienced programmers, we know what we are doing in a JavaBean won't cause any serialization problem. We have that confidence. Okay? Yeah. So we don't need compiler to check it for us. Yeah. So that's why for most of the JavaBeans you see in the market, most of JavaBeans, they do not implement serializable interface, because the developers are very confident they won't cause any serialization problem. They do not bother to attach that serializable interface. So that's why I say, optional. Yeah? You're not required to use it. If you can guarantee they won't violate the serialization requirement if needed, yeah. So you don't need to use serializable interface. Yeah. That's the reason behind it. Yeah. So I hope you understand the whole thing. Yeah. All right. Next. Define a JavaBean class. Yeah. Now we start from constructor. When we define a JavaBean class, there is some requirement for the constructor. Okay, so what requirement? Must have a zero argument constructor. Your class, your JavaBean class, must have a zero argument constructor. I hope you know the zero argument constructor. Okay, yeah. So if I use my class, okay, zero argument, parenthesis, inside it, no argument, or no parameters. Yeah. Yeah. Okay, argument parameters. Yeah. Okay, yeah. Zero argument constructor, whatever inside. There is one constructor takes that form. That's the requirement. If you don't have it in your Java class, this class cannot be used as a JavaBean. Why is that? Later, when we go to the data binding, we will understand why is that. The reason is very simple, very natural. But I will explain that reason when we talk about the data binding thing. Yeah. All right. But how to get that 0 argument? Either, yeah, so that tells you there are 2 ways you can choose. So either one, okay? The first one, the second one. 2 ways. You just choose one of the 2. The first one, you define a 0 argument constructor explicitly. You write a definition by yourself. Your class name, parenthesis, inside parenthesis, nothing, no argument, then the definition. You can do that. So that's okay. So that will make your JavaBean following the rule. Yeah. All right. Another, omitting all constructors. You do not provide any constructor in your JavaBean class. That's okay. Yeah. Most of the time we do that. No constructor. Because if you omit all constructors, Java will provide you a default constructor. Java will provide you a default constructor. Right? The default constructor is naturally a no argument constructor. Default, your class name. So what is default constructors? Very simple. I still use my class, okay? My class. Suppose that's the name of our JavaBean, okay? The default constructor, parenthesis, no argument, curly braces, inside it, nothing, okay? No code inside it. That's the default constructor, okay? So if you omit all the constructors, Java will provide this default constructor for your JavaBean automatically. So you don't worry about if you have the 0 argument constructor. This one is one. Yeah. Okay. Yeah. So that's the rule. Either one. Okay. Yeah. You take one of the 2. Yeah. That's the meaning. Yeah. All right. Access data. Now we want to look at how to access data. Yeah. First, in your JavaBeans, make sure no public instance variables. The properties, make sure all private, no public instance variables. Yeah. All right. Yeah. That's the rule. Yeah. Use accessor methods, setters, getters, to access the properties. Okay, yeah. All right. Next, naming rules for JavaBeans. Setters, getters, you need to follow naming rules. Okay? You cannot use arbitrary ways to do the setters, getters. If you violate the rules, what's the consequence? Here I want to tell you the consequence. If you violate those rules, your JavaBean classes can still be compiled. Yeah, can still run compiled. But data binding, some automatic tools working with your JavaBeans won't work anymore. Data binding is one example. Because data binding, remember, data binding happens automatically. Automatically, the reason how to make that happen automatically, your setters, getters must follow naming rules for JavaBeans. Otherwise, you won't have the data binding work automatically. It breaks. Data binding breaks. Yeah. And possibly some other tools using JavaBean specification also break. Yeah. So that's the consequence. Okay. All right. Yeah. So the components built following the rules can be recognized by the tools implementing the specification. Yeah. Those tools using JavaBeans, they assume you follow the naming rules. So they use those rules to do the translation. Okay? If you do not follow the rules, those translations all break. Yeah. None of them work. Yeah. Right? Yeah. So that's the consequence. Yeah. All right. So now I explain the naming rule. Yeah. If the property is not a Boolean, yeah. So your property, private instance variable, not a Boolean variable, the getter method's prefix must be get. The getter, you have to call get something. Okay, get something. All right. If the property is a Boolean, the get method's prefix could be either get or is. Could be is. Boolean. Boolean value true or false, right? Yeah. For example, is digit. You want to check if some property is digit or not. So you expect this method returns true or false. Is digit, true, false, right? So that's very natural. So people feel good about it, okay? Following the natural language understanding. Yeah. All right, so because it returns Boolean value. But either or, that means you can also make this the name get digit. Get digit, it returns Boolean variable, true, false. Yeah. But from the language understanding point of view, this not as natural as that one. Okay? So that's why most programmers like to use that version. But this version is still okay. Yeah. Still okay. Yeah. If you do not feel anything wrong, you can use it. Yeah. Yeah. Although most of the programmers, they will use that version. Yeah. All right. So that's the special thing about getter. All right. Then setter. The setter method's prefix must be set. Yeah. Yeah. There is no either or case. Must be set. Yeah. All right. Then the last one, there is another important property. The name of the property is inferred from getters and setters, not through any instance variables in your class. This property is one important one. Yeah. Why is that, right? So here, inferred. First, what's the meaning? Second, why is that? Yeah. So what and why? I need to explain. The name of the property is inferred from getters and setters, not through any instance variables in your class. What's the meaning of that? Right? So you may wonder, so you can understand this English sentence, but you may not understand the meaning in Java. That could be the problem. Yeah. So I want to use our last slide to explain this sentence. Last slide to explain. Yeah. This one. Relationship between property name and a setter and a getter. Yeah. The rule we just learned, right? Yeah. We just learned. Yeah. Now I want to give you more information to explain that. All right. The name of the property is what you get when you strip off the prefix get and set and make the first character after that lowercase. That's the rule. All right. How to infer? Remember the previous slide? Inferred from getter or setter. Inferred from, right? This tells you how it is inferred from a getter and a setter. Let me use a simple example. Yeah. Otherwise, still too abstract. Yeah. All right. Let me use example. Get first name. Method. Suppose you have this getter. Okay. All right. Then, what is the property name? What is the property name? Inferred from this getter. Okay. How to get it? So you strip off get. Okay. This is gone. Okay. Get is gone. First name remains, but you make the first character lowercase. So the property name should be first name. That's the property name. Inferred from getter. Okay. Setter similarly. Okay. Setter similarly. Okay. All right. Yeah. Why? The next question. Yeah. This is how we get it. Okay. How we get a property name in this way. Why? All right. Next, I explain why. Why? A setter getter is exposed to outside tools. Remember, the setter getter we make public. They are your public methods. Public methods are exposed to outside tools. Okay? So outside tools can view them. So they have a list of setters, getters. They can view. Yeah. How do they view? Here we don't know the details. We don't need to know. They have some way to get a list of public methods, not private. If private, they cannot get that list. Okay? But public, they can get. All right. All your setters, getters, all public, so exposed to outside tools. Yeah, that's the first thing. The name of any instance variable of JavaBean. Private, remember, we make private is not. Private members not exposed to outside tools. Okay? Not. So nobody can see them. Nobody can get a name. So what are the names of your private instance variables? Nobody knows. Okay? Yeah. All right. So now, so let me give you an example. Okay? Suppose we have a class called UserBean. All right. Yeah. In this UserBean class, right? Yeah. All right. We have private instance variable string first name. Yeah. Here, how about I just call it F name? Because my private instance variable, I can call any name I like, right? So here I call it F name. All right. Yeah. This is instance variable. Okay? This is instance variable, okay, of my JavaBean. Then the getter, I use this public. Remember, it's public. Public. I call it get first capital. This full first name. Okay. All right. Get first name. All right. Now, my question. The property corresponds to this getter. Is it this first name or F name? Okay? There are two possibilities. Some people may feel like that. It's not. Okay? Based on our rule, it should be from the getter, not from the instance variable. The reason instance variable private, they are not exposed to outside tools. So that's why we cannot use instance variables for the property name. Although most of the time they are equal, all right? Most of the time, Java programmers, they make this name and instance variable name, they make them equal. 90-something% of the time, they make them equal. But they don't have to. Yeah. They don't have to. Yeah. If you do not make them equal, still, it works well. Yeah. All right. So that's the rule. That's the naming rule. Okay? Yeah. The reason that naming rule is needed because we need to use that for data binding. Data binding, we need this feature. Otherwise, data binding won't work. Okay? So here I do not explain how data binding is connected to this requirement. That's the topic when we go to the data binding topic. I explain that, but not here. Yeah. All right, so that's this video, 8.3.